Welcome to the world of collecting like terms. Now, remember I said there was a difference between multiplying terms and adding and subtracting them. Um, when you're multiplying or dividing, as long as you group the coefficients and the bases together, you can do that to your heart's delight. When it comes to collecting like terms, though, when it comes to adding and subtracting terms, there are a few more rules that come into play. So first off, we're going to begin with reviewing what like terms are. And hopefully this is something you remember from grade 8 or earlier in this chapter, but earlier in this year. A like term has the same variable or variables and the same exponents on the variables. So looking at the right, identify the like terms. Take a moment and see if you can identify which terms match. The negative x and the x divided by 3. Divide by 3 doesn't change the value. If we were to rewrite it out, it would be 1/3 times x. And the negative would be negative x, negative 1, I'm sorry, times x. Well, their coefficients are different, clearly, but the variable is still the same, x and x. The 5xy, the 2xy, it has, both of them have xy, and both of them have the same degree. The negative 3x squared and the 4x, all of that to the power of 2. Although 4x is different, when we expand it out, 4x becomes 16x squared, as we learned last section. So once you compare x squared to x squared, they are like terms. 1 and 4y have no matches. It means that they're lonely, lonely people. Now, one of the things that's hard for people to understand is what difference does the number make? Now, me being a math person, I tend to think of it in the math way, and I'll come back to that one in a second. But what sometimes helps is that we can think of these things as having their own shape. So if we think of an x as being, I don't know, a log, a 2 by 4, x squared would actually be a square. So x cubed is like a sugar cube. Now, me, I made I said earlier that I tend to think of it in terms of a more mathematical way. I think of these in terms of what they're measuring. So if we think of area, it's our units squared. If we think of volume, we think of units cubed. And the reason is that when we're measuring an area of a square, we're measuring length and width. I'm pointing with my finger, and I just realized you're not going to see that. So length times width. Whereas x3 is length times width times height. So we're actually looking at 3 dimensions. X squared looking at 2 dimensions. Whereas x to the 1, it's 1 dimension. So yes, I understand that it's a square and it's just a different shaped rectangle, but we do it this way because a number, say the number 1, tends to be represented by a small square. And we can represent both positive and negative. I'm usually just do it this way, put a negative sign in there. A lot of them will do like red and blue or black or something like that. So if we're looking at, say, 3x using our visual model, what it means is that we have 3 of those stick thingies. If we're doing 2x squared, it means we have 2 of those negative ones. Now, 1/4 x cubed, a little harder to show, but we draw the shape, and then we just take 1/4 of it. And that's all we're using. Okay, not a great example, but, and this is handy to understand because no matter how much we try to put an x with an x squared, they're different shapes. They will always be different shapes. And we're not going to get into the stupidity of if we nail them together or if we grind them up or some silly thing like that. We will always have a straight line with a square. So collecting like terms. This means that we're going to put terms that are the same together. And the goal is to have as few terms as possible, right? Let's face it, kind of like going into your room, we just don't like having that much crap on the floor. So it's time to clean up and get rid of as much of it as we possibly can. So first thing we got to look at is we got to identify like terms. Oops, that's not what I wanted. I wanted that. We got to identify like terms. Now, when we're grouping it, it's all about addition subtraction. Okay, that is a big one. Remember, what we were looking at yesterday was multiply division. Don't care. You can multiply and divide anything you want. But grouping like terms applies for adding and subtracting. You can only add and subtract like terms. Integer rules and coefficients, everything's the same, and the variable doesn't change. So unlike multiplication, when you multiplied x times x, you got x squared. Well, if you do x plus x, you're going to get 2x. So the coefficient changes, but not the variable or the exponent. Let's get into some examples. So here we have an expression, 2x plus 3x minus 4x. Visually, it's going to look something like this. If it'll draw. And I'm going to do them in order. That is a horrible square. That's another horrible square. Wow, I am struggling. You know what? We're just going to get rid of all those. Oh, we're getting back to ugly land. That's better. Oh, nope, back to ugly land. Now, by the zero rules, these two match up and disappear. So we're left with 1, 2, 3, and 1, 2. Let's not forget our equal sign. Otherwise, I'll have Keegan getting mad at me for not writing out the equal sign because I bug her about it. Algebraically, what we're doing is we're identifying what terms match what. Let me slip back into my other thing for just a second. I'm going to change color here. Notice that there is a difference in colors, or a difference here. Notice that when I drew my box around it, that subtract 4, I'm including the subtraction sign with the 4, making it a -4. So when I put them together, 2x minus 4x, in other words, 2 minus 4, gives me -2x. Okay, the coefficients changed exactly the way they would using integers. 2 minus 4 is -2, but the x's don't change. We started off with an x and an x, we finished with an x. The 3x squared doesn't change because it's got no dance partners. It's still doing its own thing. All right, hopefully that's clear. Let's try a couple of examples. They're fairly straightforward, so I want you to give them a shot first if you can. So first off, let's identify the matching sets. We have a 2x and a positive 3x gives us 5x. In this case, we have a -3y plus y, which means we have a -2y. -3 plus y is -2. Okay. B, we have an x squared, we have a plus 3x. 5x squared. We have a plus 5y. It's got no playmates, so it just stays as a plus 5y. All that's left over is a plus 15 minus 2. Now, I want you to notice something. I'm putting these in order of their degree. So notice that it's the squared is to the left, the 1 is in the middle, and the 0, because there isn't one there, is to the right. This is, you will not lose marks for not doing this, but it is a good habit to get into. Again, 2x squared, negative 2x squared. So the two of them combine to give you x squared. That's an ugly squared. We have 7x minus 2x. So that's plus 5x. And then we have a minus 15 with a plus 3. And that gives us minus 12. Last one. 3a, 12a, combines for 15a, plus 2b, plus 7b, plus 9b, and then what's left over is a negative 6ab and a negative 3ba. Now, hopefully you remember in multiplication order doesn't matter. So AB is the same as BA, which means that these are in fact like terms. In which case, that's minus 9AB. All right, guys. So hopefully that's good enough to get you up and running. It might seem like a lot of homework, but it'll actually fly by pretty quick. Thanks and good night.